right. Remember the last time we just introduced the concept of a mole, all right? Molecules, because we're counting the number of molecules that we're going to be adding. Because at the end of the day, for every one of these, we need one of these, so we add only enough to do the reaction. Why? Because if we add too much, we might not end up with the correct product that we want, i.e., remember, too many eggs, we end up with a sloppy mess. We end up with an omelette instead of a pancake batter. Or if we add too little, we end up with this gooey, soggy lump. And the same thing applies in chemistry, because after all, if you think about it, baking is really chemistry, isn't it? You take reactants, ingredients, add them together, do stuff, heat it, cool it, or just add them together, and what do you get? You get a product, you get a new thing, all right? Now, let's have a look at calculating molecular mass of stuff, right? First of all, I want, if you've got your periodic table there, or one pretty close by, okay, I want you to have a look at something, right? Have a look on your periodic table at your elements going across, right? And let us look at carbon. Oops. Carbon, right? You will see at the bottom of the carbon, on mine, I've got it as 12.011. Okay? Where does that 0.11 come from? Can you remember? It comes from isotopes, doesn't it? There's some carbon-14 out there. We spoke about that with carbon dating. So it's not exactly 12, right? But for our purposes, we actually round that to a 12. Let's look at hydrogen. Okay? Hydrogen has got a 1. It's actually 1.00 something, 0079. The reality is that's because of deuterium and tritium. Remember? The one with the 1 extra and the one with the 2 extra, right? So underneath here, we have got a number. This is called the atomic mass. Atomic mass. Fundamentally, all it means, right, is it means that if I take any one of these and look at the number under it, all right, look at the number under it, the atomic mass, it means, okay, this. It means that if I take carbon and I weigh out 12 grams of carbon, guess what I've got? 1 mole of C atoms. If I take 1 gram of hydrogen, I've got 1 mole of H atoms. So let's have a look what's oxygen, okay? If we go, oxygen over there at the bottom is got 15.9999, it's 16. It means that's the atomic mass. What does it mean? It means 16 grams of O. Let me rather use the one we always use. 16 grams of O. Please be careful here. Be very careful with the diatomic gases. Hydrogen and the 7 starting with nitrogen and ending with astatine, right? That group there, or that cluster, contains 1 mole of O atoms. Any of them. Copper, 63.5. Therefore, 63.5 grams of copper gives me 6.02 times 10 to the 23 atoms of Cu. Why? Because that is 1 mole. That's the size of the bucket. We've defined it. A bucket of anything contains 6.02 times 10 to the 23 of those things, right? Simple as that, okay? And actually, just bear with me because it doesn't really get more difficult. There's not really much in this, Okay, it looks more difficult than it is, personal opinion anyway. So we say, right, now we've identified this important thing, all right? So this here, this atomic mass that we've got at the bottom here, that is measured in 63.5 grams per mole, right? Because 63.5 is 1 mole. Therefore, so many grams per mole. Well, let's have a look. Let us say that we've got 36 grams of carbon. How many moles is that? First thing in chemistry, we look up the molar or molecular mass, okay, which is of carbon. You go across and look under carbon and you'll see 12. This is 12 grams per mole, right? Which means, just let's look at this. This is one way of doing it, all right? 12 grams is 1 mole. 12 grams per 1 mole, right? Because if I weigh out 12 grams, I've got 1 mole, haven't we? So 12 grams is 1 mole. Then we put in the table here 36 grams is how many moles? If we don't know what something is, whoops, we don't do that with it. If we don't know what it is, what do? We call it X. The next step is we cross multiply. So 1 times 36 must equal 12 times X. Therefore, X is equal to 3 moles. All right? As you get the hang of this, it becomes a lot simpler and a lot quicker, and you start seeing it straight away. For example, let's have a look and say, okay, let's have a look at, and they say we've got 12 grams of magnesium. No, 12 grams of potassium. Right? Now we go and we say, right, let's look at potassium, and we go and we work out molar mass, mm. I abbreviate it to mm, okay? Just to keep it shorter. Mm, 2 capitals. Think of it as McDonald's, mm, right? So what do I have? Potassium, 39 grams per 1 mole. So 1 mole is 39 grams. So I say, right, 39 grams is 1 mole. Then I fill in, what have they given us? 12 grams. Therefore, X is the missing moles, right? Cross multiply. So what do we say? On the cross multiplication, 39 times X there is equal to 1 times 12. Therefore, X is equal to 12 over 39, which is going to be, and we haul out the trusty calculator and we say, all clear, 12 divided by 39 equals 0.3077. 0.3077 moles. And I always take it to 4 decimals here, okay? That's what I do, okay? You will obviously be told, but it makes quite a big difference when you start to look at the number of atoms and things. But you'll always be told, same in math, same in everything, to how many decimals. So do look and see what they tell you to do, all right? But generally, if you take it to 4, I think that's pretty safe, okay? Now, let's have a look. What do we say next? All right. Let's say they tell us we have got 0.75 moles of, let's pick a different, aluminium. Naught 0.75 moles of aluminium, and they ask how many grams? What mass have we got? Grams? What mass? Okay. These are the questions I ask. Well, 0.75 moles, always, first thing, find the mm. Molecular mass of aluminium, 27 grams per 1 mole, right? Therefore, what do we say? 1 mole equals 27 grams. Therefore, 0.75 moles equals X grams. And what do? We first of all take this up so that we can put space. Then we cross multiply, right? We say 1 times X equals 0.75 times 27. Therefore, X is going to be equal to 0.75 times 27 is 81 over 4 is going to be 20.25 grams of Al. Right? Now, this is basically a few practice shots of that and it's sorted. Let's now up it a bit, okay? Let's up the bar, right? Let's go more complicated, shall we? Let's say we've now got, I don't know, hydrogen chloride, HCl. Whoa. Now we've got 2 different things, right? What does this actually mean? What's it consist of? What did we've got? We've got 1 hydrogen plus a chlorine atom. That's what we've got, eh? These 2, a hydrogen and a chlorine, right? They came together. We did the electronegativities, we checked if it's polar, covalent, ionic, what kind of bond it is, etc., etc., etc. And then what did we do? We said, right, you form, there you are. There's HCl. Hallelujah. Now what? Now we say, okay, how much does it weigh? It's a molecule, right? Composed of 2 pieces. So how much does this weigh? Hold on, let's see. Okay, I'll weigh you. I'll take you off, write it down. I weigh you, take it off, write it down, and add the 2 together, don't I? Why? Because it's the mass of this plus the mass of that, isn't it? It's mass 1 plus mass 2. Whatever. What about magnesium hydroxide? MgOH. Now be careful. If they say in words, the recipe says magnesium hydroxide. They've told me in words. I first of all put down Mg and OH, which is my hydroxide. Then I go and I say you're a -1, you're a +2. I then have to multiply you by a 2 to balance the charge. You become therefore a 2, and I've done with the little subscript numbers. Okay? Right. So, in other words, Mg and OH2s, right? But be careful, these OH2s are split, okay? There's an O and an H and another O and an H. Because let's strip it apart. We've got the mass of a magnesium, the mass of how many O's? O, there's 2 times 2, and hydrogen times 3. Okay? So the mass of that is the mass of a magnesium, isn't it? Sorry. The mass of magnesium, let's have a look on our periodic table. We go underneath, 24. Okay? I've got 24.3, all right? But let's just use 24. Right, I've got 1 atom of this guy. Here it is. There we go. There's my magnesium. Okay? And I've got 1 times 24 grams per mole, right? 2 oxygens. Here they are. So each oxygen is, let's look, 16. So we've got 2 times 16 grams per mole, haven't we? And we've got 2 hydrogens. Silly me. Okay, I was obviously doing 1, 2, 3. Remember, we've got 2 hydrogens here, right? That is 2 times 1 gram per mole. So let's add it. That is 24, 32, and 2. So we've got 24, 32, and 2. Now let's add 24 plus 32 plus 2 equals 58 grams per mole. Now we know, therefore, we now know the molar mass of N magnesium, Kevin, not M, magnesium, MgOH2. The molecular mass of that is 58 grams per 1 mole. All right. Let's take sodium. Let's take the sodium carbonate one. No, let's take ammonium carbonate, right? Okay. Right. Remember, ammonium was NH4 and carbonate was CO3. Now we don't know, so we've got to say, whoa, hang on. CO3 was -2 and NH4 was +1. So what does it mean? It means that I need to have 2 of these and 1 of those, but we don't write that one at the bottom, do we? Okay. Let's just go through that process again, shall we? We say, right, first of all, they tell us in words ammonium carbonate. Actually, let me just erase it. Just go through it one more time with me, right? We have ammonium is NH4, so we write it down. Carbonate, CO3. They've told us in words, so we now need to go and balance this out with these small numbers at the bottom, okay, the subscript numbers. So what do? We always go to the valencies. The valency of this carbonate ion, -2. The valency of NH4, remember NH3 plus 1, okay, was uncharged. And what did we do? We added 1 proton. We added another H on there, plus an H, which is a positive. So it was a +1, right? Whoops, let me just get rid of this. Okay. We added a proton on, so it became +1. Now, so we've got this NH4. Now it's combining with a CO3, carbonate, which means I've got a +1 and a -2. So if I just put them together like that, it's going to have a charge of +1, -2 equals -1. But ammonium carbonate is a powder. It's a substance that's not charged, right? So therefore, we have to balance it out. Therefore, we say, right, I have to have 2 of you, okay? And there's my ammonium carbonate. Now I say, okay, right? Let's just, I'm going to remove those numbers at the top just so that we don't, that's what we've got, ammonium carbonate. Okay, now let us say that they tell us that we have got 112 grams of that as a powder. Okay, how many moles? How many moles? What do? Always, we go and we say molecular mass of U. Right, now let's have a look. Oh, we've got a 2 outside the bracket, which means I've got 2 N atoms. I've got 8 H atoms, 1 C, and 3 O's. Right? So if I split it up, there's 2 N's, 8 H's, 1 C, and 3 O's inside this compound, right? This mixture's got that in it, hasn't it? Okay. Now we go to nitrogen and we say, okay, nitrogen is 14. So it's 2 times 14 grams per mole. 8 times 1 gram per mole. 1 times carbon, 12 grams per mole. 3 times 16 grams per mole. Then we do it like this. And all I can tell you is, please, when you're doing this, be neat and logical and tidy. Okay? You will make mistakes if you don't just follow the little sequence of events like I've done here. Okay? Eventually, obviously, those of you that get faster, you will find that you're able to do it using brackets or whatever. Fair enough. But it actually is the same amount of work to do it this way at the end of the day, I believe anyway. So that is 28 grams per mole. This is 8, that is 12, and this is 3 times 16. I've picked up my calculator, although I know what it is, but I'm double checking. Grams per mole, grams per mole, grams per mole. I know I'm writing it a little bit quicker, but at the end of the day, we add them up, don't we? Why? Because we've now worked out the individual masses, and we must put it all back together to form the one molecule of ammonium carbonate. So let's add them up. We have got here 28 plus 8 plus 12 plus 48 equals 172 grams per 1 mole. Therefore, 172 grams is equal to 1 mole. What have they said to us? Let's relook. We've got 112 grams. So let's fill in what we've got is equal to X moles. What do? We cross multiply. Therefore, okay, let's just move it down a little bit. Therefore, 172x is equal to 112 times 1. Therefore, x is equal to 112 divide 172. 112 divide 172 is equal to an SD 0.6512. 0.6512, and I'm working out moles. All right. Last one. Let's take, for example, they tell us that we have got sulfuric acid, H2SO4. Remember, plus 1 times 2 plus 2, SO4 polyatomic ion minus 2. Okay, what do I do here? I break it down and I say I've got 2 H's, I've got 1 S, and I've got 4 times O, all right, which is 2 grams per mole. Sulfur, let's look it up, 32. 1 times 32. Okay, I've just 1 times 2, right? And 4 times 16. Right? So this is 2, this is 32, and 4 times 16 is 64. So that's 64 plus 32 plus 2 equals 98 grams per mole. And now they tell us, they say, okie dokie, I am going to say to you, I have got 0.65 moles. And they want to know, what mass is this? What mass is it? Well, put down what we know. Remember, we always go to molecular mass. We say, right, the molecular mass, I say, 98 grams, here we go, equals 1 mole. That's the molecular mass. What do I do next? We say, okay, what are we given? Okay, we're given 0.65. Therefore, X. Now, cross multiply. Right, like so. And we end up with what? Okay, back to this. We end up with 1 times X equal to 0.65 times 98, which is times 0.65 equals, divide by 10, 63.7 grams of H2SO4 is in there. Okay, we've done quite a few of those. I'm ending off now in this one. We've done quite a few of those actually. Can you see that all it is you say, you write it down, make sure that the bottom subscripts are balanced. How do we do that? We've got to know the valencies of the element or of the polyatomic ion. The element we get from the periodic table, except the ones in the transition elements where we've got to know some of them as standard ions, anions and cations. Anion, is that the negative or the positive? Anion, another negative ion. It's the negative ion, okay? We've got to know those. Then we just break it down and multiply by the atomic mass of each one. add it together, and that tells us the weight or the mass, my apologies, of that single molecule on its own, right? And then we just use the simple ratio of so many grams per mole, and then fill in what you're given and cross multiply to get the answer. Okay, the next one we're going to do is we're going to start looking at, empirical formulas, okay? And we're going to look at percentage compositions and things like that, okay? And the last one, eventually, we're going to do a few chemical equations, and we're going to say how much of this must we add to that, and then I'm going to show you a table, okay? And that table is something that I'd like you to actually really commit to memory. Thanks for watching. We'll see. We've probably got 2 more to go. Thanks.